Hello, Amiga coders. This is Photon of Scopex, and we are continuing with the cloud layer. What I did was to just shrink this cloud that I made and touch it up so it looked good, and then I cut it out like bobs, like this. Let's see here. And wrote them both as bobs and mask. So that part is prepared. And we have loaded the source here. So last time we moved two clouds. We actually just moved one of them. And now we're trying to make a multi-layer parallax cloud playfield. Those are our two clouds. We have some margin at the left side of the screen, but as soon as it disappears outside the right side of the screen, you can see it gets messed up, and that's because it is an interleave display, which means it passes into the higher bit planes, and that's why the colors are messed up. But now the cloud should be restored to normal again because it has passed by 3 times and the playfield is 3 bit planes deep. And now we can't have that, so we need a check for the margin. We have a design decision to make. We have some stars moving faster than clouds, very logical, but I think as a design choice, we're going to keep that. I'm going to keep the stars, I'm going to keep the clouds, and the clouds will be moving slower than the stars, presumably. We'll see about that. Main thing is they don't lock up with the stars, if you know what I mean. I don't want them to travel at the same speed as the stars, so that the stars seem to belong with with the clouds. We'll see what we can do about that. We can also switch the direction of them, but it would be a little bit illogical to have the stars go rightward and the clouds go leftward. It is already illogical because the scroll is moving leftward, as scrolls tend to do. Except for, well, we don't have to go into the subject of Arabic alphabets and so on. I don't know if scrollers scroll rightward in the Arab world. Arab coders might be able to answer that one for me. So now we need a limit checker, and we need to check our buffers. First of all, we're going to do a little test here. I'm going to see where we plot the bobs. We have one fixed one. We have a single variable for one cloud that will be changed into one variable per cloud so that each cloud can move at its individual speed. And we can sort of simulate a parallax layer here by first of all correcting this horrible thing. Replace this fixed x with that and halve the speed. So shifting by 1, reasonably that should be an ASR, which is safer than, so nothing bad happens when we go into the negatives. But we're going to set a max x for the clouds, at which point as soon as they are fully out of the right margin and no longer visible, they will be moved to a little bit outside the left margin so that they can come in on the left side. So that takes care of the speed. Now this is the clear blit. Might behoove me to write a comment about that. Um, and we only have one add here because we first want to clear the old position, then update the position, and then plot the new clouds at the new position. It is the same as if you would plot a pixel. If you would move a pixel on the screen, you would erase the old plot and update the position and then place a dot where the new position is. And here too we must replace the fixed x. Well, we did that, didn't we? Well, we can copy both lines here. So now we have two moving clouds. One moving at half the speed of the other. This means that if the speed, since the speed is 1, it's moving at a half a pixel per frame, which means it only updates every other frame. The position stays the same for 2 frames and then updates. That you could mess around with it and make a design decision that all clouds should update every frame to make it smoother. For the purposes of this tutorial, we will just, the only purpose of creating these cloud layers, is to use up the raster time. Right now we're hardly using any. We can check that. Let's go to our part 1 and see what that's called actually. And when everything has been done in that part, we're going to change background color. Let's do that. That's the custom chip register for the background color. I will go into using symbol files in a later episode. We're using symbols for the blitter registers only at this point. So if you can see where the gray color starts, that is the last line of execution in part 1 for each frame. So that means we're using about 1/3 of the available frame time because we are executing the code starting at the first rest line at the top of the screen. The reason why the endpoint, normally if there's not too many objects spawning and despawning, appearing and disappearing, the execution time stays the same for each frame. However, we're playing music, and that's why it's jumping. The play routine has more things to do every 6th frame or so than all the other frames. It also decrunches notes and does some other things. So that's why the execution time varies, but we're hardly using any time here with these two quite big clouds. We're looking to add, let's say, 10 more clouds to fill out the sky. Now for the next demonstration, which is, let's change this to something more palatable, like, I don't know. And let's hope that's different. Let's do this. Let's hope that's different from the blue background color. I want to demonstrate the thing that we have not implemented yet, and which is the topic of this tutorial, apart from adding more clouds. And that is buffering. Let's check where we plot bobs again. So we don't know exactly when this occurs, but it's placed in part 1 after all the initialization code, after we've initialized the buffers, played the music, etc., etc. Excuse me. Now, what I am about to show is chasing the raster. So, if we were to move this up, either of the clouds, move them up, let's say to position 0 vertically, you can see this, for the most part, unwanted behavior. So if you can see at the top there, at the top of the logo, there's a blinking part of a cloud. And the reason that happens is that's when the first blit finishes. So we know that we are somewhere here for this cloud. That when we start this, and then it takes a certain amount of raster lines to plot this bob, and we can just see the bottom edge of that cloud, which gives us some idea. But this is unwanted behavior, right? We want to fill the entire screen with bobs. And they should be able to go all the way to the top. So what we need to do is to double buffer. You can have any number of buffers. You can triple buffer, you can quadruple buffer, etc. But for our purposes, we only need 2. To do this, we must update the bitplane pointers we only need to do it for that playfield, the cloud playfield. And we need to find out what the name of the label is that has the screen buffer for the sky. It's simply called sky. And we made a sky loop for the stars. I guess they're part of the sky too, but they are updated independently, and they are not updating the buffer, which means that they don't flicker like the buffer does. We are looking for where the bitplane pointers for the sky are poked into the copper list, are placed into the copper list. We have something here. Oh, that's the plot bob. Here we have some init code. That's a clear loop for the sky, a very simple one. Now we have a blitter routine, so we could potentially do it with a blitter clear. We will come into optimizations in a later episode. Playfield 1 pointers. That's the logo. And here's the Playfield 2 pointers. Let's place a marker here. So, first thing we need to do is to double up on the buffers. We need a sky and we need a sky 2. We need to clear them both in the init routine. And we need to swap them every other frame. We need to swap them every frame. Correction. So what this does is simply to put these 3 bitplane pointers into the copper. Now, the correct execution time for this code during a frame is before the sky buffer is displayed on the screen. And it starts at raster line hex 2C, which means this code must be executed before then. And the correct place for it is normally in the vertical blank interrupt. And part 1 is called at the vertical blank interrupt. So we're all good here as long as this is at the start of part 1. Basically, all initializations of the copper should happen either at the vertical blank or at the end of a frame if you prefer to not use a vertical blank interrupt. Simply so that the copper is ready and doesn't contain any unupdated information for the next frame. So that is the correct preparation. We have this loop here. We'll need to make this dynamic. We can't have this fixed pointer to put in the copper list. We need to fix the init loop to clear both of them. We need to make the bob plot routine dynamic to poke in the current buffer. We'll have a shown buffer and a hidden buffer, and the hidden buffer is the one you draw into, which means that this part here should put the buffer to show into the copper list and then switch. Oh, sorry, this loop. This loop here should put the buffer that is to be shown into the copper list in preparation for this frame, and then immediately swap the buffers. Then for the rest of the frame, that pointer should be used to draw into. So first things first, let's go to our buffer. Let's put a mark here, and let's go to init also and put a marker here. And let's duplicate this buffer so that we may have two. They are of equal size, of course. And then we'd like a list, which does not go into this BSS section. The BSS section, again, is just a way to allocate memory. It doesn't contain any data. That's why the declare space instead of declare byte or word, or indeed block. Now, we can put that buffer list at a good spot in the source code. We can make this read that list, but it's not really necessary, which means that we can either duplicate this loop, or we can add a duplicate pointer, which will save some cycles and some code. And since they are of equal size, this counter here will work just fine. So to recap, the same loop that cleared the buffer that A1 is pointing to now has a second pointer. Maybe it's simpler to understand to just copy the loop. However, it's good to show. Since the clear loop is so unoptimized anyway, let's keep it that way. We can add a comment saying clear second buffer also. Now, if the buffer is different size, you can do this. You would have to copy paste the loop and modify this counter. I hope that's self-evident. So much for the buffer and the clearing of the buffers. Now we need a buffer list. We have some variables here. We can put the list here. Now, if I declare this here, this is not really necessary to say. We're not at that stage in the tutorials yet. But well, it's not hard coding, but writing a so-called reloc32 address, an address that is pointing at an unknown address that hasn't been mapped yet because it's in the BSS section, will require a relocation of the demo. And maybe you don't want that. If you make an intro or a boot block or something track loaded or anything like that, you might want to cut down on the so-called relocs, the number of relocations. And then you can avoid this. You can just declare the space for them and poke them dynamically in your init code. But for now, this is the simplest solution. So this list will point to Sky. So the first thing that will happen, let's see here. This is fine. We're gonna figure this out together. This is fine for now. That's our double buffering buffer list. We should name it Sky buffer list in case we need another buffer when we start adding work to the loop. So much for the buffer list. It already contains these values, so we have to do nothing. Well, do we? It's a BSS buffer. Let's do what I said and just declare it as 0. And let's go to the init code. And since we have them ready here, let's initialize Sky buffer list with these 2 pointers. Now we've done it dynamically, and it doesn't really matter what this points to. This will all be sorted and then initialized. It's important that the init code does this before the first vertical blank call, because otherwise it will poke, it will read the zeros we declared and initialize the bitplane pointers with the zeros. And the buffer list is now initialized. The next step is to update the vertical blank interrupt. Make sure that we are at the start. Let's see here. Oh, we need to move this. Look at this. This is not dynamic. This is in the init code. This must be moved out. We can still keep this here because it's a decent default. It will make sure that the copper list is initialized at the start. We can keep this here, but we want to copy this now because now it's dynamic, right? It's changing, which means we need to go to, okay, let's see what it's called. VBInt. Let's put a marker here. And we'll simply put this before anything, so that going forward, the first item in the buffer list is the pointer you draw into. Now, we didn't copy the A1 pointer, so this is now running rogue. We need to go back and fetch that. Let's create a label. Copper sky bitline pointers. Let's go to the copper, and it was here. And we'll simply type cop sky BPL pointers for playfield 2. And we can actually copy that. To make sure that it puts the pointers at the correct spot in the copper list. Now let's double check here. Yep, we're good. This will now toggle the buffers, and if you don't use this, we're doing no swapping right now. This should mean, let's write this because strange things can happen, and verify that everything is as it should be. Oh, we misspelled it. Put a marker here. A stray Y. So it would seem nothing has happened. You can still see the, barely see a few pixels of the bottom of the cloud above the logo. So nothing has happened because the copper is pointing to sky, not sky 2. Still pointing to the original buffer, and we're not swapping the buffers. Now, if we swap the buffers, it should obviously flicker because we're still only drawing into one of the buffers. We're not drawing into one while showing the other. So immediately after poking these, we need to make this dynamic now. The init code can be fixed, it's fine. But this is to be made dynamic then. So we can't use a layout, we need to use a move L. And we need to create a new variable. No, we don't. We put the first pointer in the list of 2 pointers. Into A0, and that's our dynamic. So this should change nothing. We can verify that, but it's unnecessary. It will read the first word in the list right now, which is still, hang on. Well, which is dynamically initialized in the init routine to sky. That's the init code. This is the vertical blank. So before we draw anything, before we call part 1, You could also put it first in part 1. That might be a better spot for it, but for now this is fine. This is just behind the scenes code that prepares everything, and the actual action takes place in here. I'm good with that. Now after we've poked the copper list, we need to swap the items in the list. And the simplest way to do that is to use a movem. And exchange them. We don't need to use address registers. Let's do it for now. And move them back in the same order. And this then constitutes the swap. And what this should result in is a flickering at half a frame rate. So every other frame will show sky, which the clouds are being drawn into, and half of the time it will show an empty buffer because we cleared it in the init. That is not the case. Interesting. Do not see the bottom of the cloud at the top anymore. So, depending on which frame I clicked, the order of the list should be different. We can examine that. Oh, they're set to the equal value. We need to fix that. So that's only a problem in the init loop. So what happened was the not init loop, the init part put to the same pointers, both pointing to sky, not sky2. You need to make it so that we can compare this value, 436EO, to this. So the buffer list now contains sky and sky. We need to change it so it contains sky and sky2. That's the pointers, but I wanted the clear loop. This is still fine. And that's the error. A simple editing mistake. Now, while using, it may flicker irregularly on your screens, and that could be because the recording is not syncing perfectly. Now when we examine the sky buffer list, it could be the same as before. Yeah, it has sky and sky2. But if I run the demo again, these pointers should be swapped. So now we need to make the top cloud appear again, because we can no longer see it. And the way to do that is after we've swapped the pointers, now for the rest of the frame, the first item in the list is not the shown pointer, but the one we want to draw into the so-called back buffer. Back we go to our bob plots, and we make sure that the bob plots use the correct screen pointer. And all we have to do is change this out, get the first item in the list, and use that instead. You can see if we need to reload the screen pointer anywhere. If not, then all of these operations occur in the back buffer. Not quite as expected, is it? And we have a bit of a bug as well. Interesting. Now, what I did was, in theory, correct. The only problem is the execution on your ideas. And it could have to do with when we swap the buffer pointers. We can examine the sky buffer list again. And now you can see that the pointers are swapped because sky 2 comes first in the list. We can check the plots again. This is the most likely source of the error. But it seems okay. Let's go to this routine. Does preserve A1, so there's no problem there. And there's no hard-coded use of the sky pointer in the subroutine. So back we go and check our bullshit. You are the best person at checking your own bullshit. I like to do that before I speak. Can correct that. That should be fine. The clearing should be fine. So what happens now is that the reason, I can show the reason for one of the bugs. The top cloud is probably not visible because we are still drawing into the showing buffer. I hesitate saying that, but... And the reason for the trail behind the lower cloud, you can see it leaves a plot behind. The reason for that is that the cloud goes all the way to the left edge. There's a pixel at the left edge. We are clearing a rectangle. We are not stamping the outline of the cloud to erase it. But because we are swapping buffers now, we need to remember the position of the previous position of the cloud. You can no longer have this code. Let's see where we are. You should still clear and draw in the same buffer. However, when the demo gets back to the same buffer, it will be 2 frames later. That means our buffering is working. And all we have to do is, when we have drawn this cloud, these two clouds, we must save the position it was drawn at, and 2 frames later reload that when we clear it. So this calls for a list of cloud X coordinates. That's the best and really the only way to solve this. I could jimmy it by let's see, subtract, because I know the speed, I could subtract 1 from cloud X and add 2 back. And that might fix it, but it's not the correct way. We need a list of coordinates. And we need an available address register that will not be overwritten by plotbob. So let's see if we saved this. Yeah. Can update this to clouds because we are plotting 2. A6 is used for the custom register base address. I'd like to preserve A1 throughout. I don't know why these have to be reloaded here. It seems like we preserve them. Let's check. Well, I don't modify them, but we can't obviously use them for a pointer into a coordinate list. Seems like A3 is free. Let's check. A3 is available. And this coordinate list must also be double buffered, or you can have it as a history buffer or whatever you like. But so we need to make a pointer just as we did for the buffers. Cloud coord P. And that's where we start reading our coordinates. And then we need to swap that in the middle here. No, we need to swap that. You should always swap buffers at the same time. So we'll swap this pointer when we swap the buffers. This is the one we act upon, just like the screen pointer. So these belong together. And because we're going to have, we need a pointer because we don't load the cloud coords L here, not the list. We want 2 lists separate because we need many coordinates now for the clouds. And the entire list should be toggled with a pointer. So the pointer will either point to list 1 or list 2. And then we start reading coordinates from that instead. We'll also add an individual speed to each cloud. which means that D0 will now read the top cloud's coordinate. We'll make this into a loop in a bit. And after it's plotted, it will update the position. It might be better to move it first. How do we feel about that? I think I like that idea. Let's update it first. Because then we can also put a check in. And that check, because the cloud is 112 pixels, the widest cloud is 112 pixels wide, we made the screen buffer for the clouds 112 pixels wider than a normal screen. We can verify this. So instead of 40, we have 54, which is 14 more. And 14 times 8 is 112. So we move the cloud, but now we also check against, we'll use a hard limit for now. And this is an unsigned comparison, really. You can do this however you want, but I'm going to do that. Keep forgetting my shortcuts here. There we go. And if it is that big, we're going to wrap it around by subtracting as much. You could clear D0 here. However, if you're moving at a certain speed and the speed is not divisible by this total number here, then the cloud will stagger a few pixels. So it's better to do this for all wrapping operations. And after we're done, we need to move it back at to replace coordinate. Because we've increased the A3 register here now twice, we need to go back by 2 words, we need to go back 4 bytes. And poke it back in the list. Now the good thing about this piece of code here is it's recyclable. Is this a time when I make this into a loop? Let's do it like this first, and then we'll convert this into a loop. A loop of 2 seems excessive. So once this position is correct, then we can plot the first bob to delete it. So now I'm thinking that this update code should happen after this plot, and that this should not be a clear blit. We shouldn't have 2 clear blits and then 2 plot blits, even though it's kind of handy to keep this a variable. We'll reload it before each plot to determine whether it's a clear or plot. We can still do this if the subroutine preserves D0. If it does not, we need to know. This is turning more and more into a loop because of, laziness and duplicate labels and stuff like that. It does not preserve D0. Does it change D0? Well, it won't tell me because I don't have the latest code in this version of Asm2. It uses D0. I'll have to check it manually. Yeah, it does. So now we have the option of preserving this, and I think I want to do that. To make the outside code simpler. So now we have loaded the x-coordinate. We erase the bob, and then we move it. And then we plot it. And by swapping the coordinate, the buffered coordinate lists, it will read from the coordinate list that belongs to the screen buffer where the cloud was last plotted into. Let's move this down for now. We're going to make a loop of 1 just to test things. We'll not bother with the other bug for now. We'll fix this plot trail bug first. So we clear the bob. We move the bob instead of just adding 1 to it. And we don't need to load this because it's loaded from the coordinate list. And we might need to reload this. So this really belongs in the coordinate list as well. Let's do that. And let's make the plot bob routine preserve that register also. Now this will make the list different in structure. It will be 3 words instead of 2. So we need to correct this offset. And now we have the actual current position of the cloud ready to be plotted into the buffer. Preserve this. Preserve these. Are they the same? They are the same. And all we have to do is plot this bob now. So the clear blit now reads the last state of the coordinates in the coordinate list for that buffer, immediately acts on it and erases the bob in the old position. Then it updates the coordinate for the new position for that buffer, writes it back into the list. You can do this after, that's fine. But while I have it, and D0 belongs with the other operations here, I write it back before I draw the bob. And all we have to do is change the mask, the min-term, and plot the bob in the new position. We can delete this. Since we're only drawing one cloud, we don't need to make this a loop yet, but we will. We must also not forget to also save away D1 on the stack. But we have not yet created the coordinate lists or the coordinate list pointer, which means that should be called list pointer. Cloud coordinates list. Let's put them with the others. We'll have a cloud cohorts list pointer. Now this is not in a BSS section, which means we can actually initialize it in the binary. And then we need to declare these. If you're a purist, you would declare the labels before use, but we're fine. And then we'll swap the pointers as we swap the buffer pointers. And now we can create the coordinates themselves. So this is now starting to look like a demo or a game or whatever you want, where you have a bunch of objects moving around and you have a coordinate list for them that you update. And with this you can do a lot of things. You can apply physics to them. You can make them bounce off the sides of the screen and so on and so forth. We'll just have the x at 0, the y at 118, and the speed at 1. We don't have a loop yet, but when we do, we'll need an end pointer for to know when the list is out, or we use a fixed count, which is more likely. So let's match up the offset. We used a -6 offset, and that seems correct. Let's double check the order in which the data is read from the list. X, Y, and speed. We can say that this is X speed instead. And now we'll no longer get the cloud looking bad when it disappears off the edge of the screen. Now, if I run this code now, it may result in stuttering. And that is because we're not swapping the cloud coordinate list pointers. Let's do that at the same spot where we swap the buffers, so that one coordinate list belongs to a certain buffer. And we'll do that the same way and just change which 2 pointers we are swapping. And let's check our bullshit by pressing J. seems to me that the cloud is moving too slowly. This should tell me. So there was a pause there because it disappeared. Okay. So as you can see, it didn't correct itself until it had gone all the way around. So this part was incorrect. I need to compare it to, well, it should be correct. God damn it. Well, we're doing it wrong because it should be this, right? That's not correct either. And that is the correct wrap value. We are adding 14. We forgot to add 14. That's a problem. Or did we? Yeah, we did. Let's separate that out. Previously, we had a pointer of sky plus 14 in the copper list, and we need to correct that so that it is correct. So this resulted in a delay before the wrap occurred visually. So this should now at least allow the cloud to wrap around horizontally. Still not seeing it. We can double check the sky buffer list. It does seem to be correct. It is correct. So what error have we made? The sky buffer list is correctly initialized. This should clear the entire buffer. So these pointers are correct. It does clear both buffers. It does set a nominal value for the sky buffer. Now, a different way of doing this would be to raise the raster, try to blit clouds ahead of the raster from top to bottom. And what that does is it removes double buffering, which means if you're making a game, you won't have extra input lag. I'm just throwing it out there, but I still want to show the correct technique. In a game where an object can be anywhere vertically on the screen at any time, you will need to sort the objects vertically in order to do this, and it is the right choice if you're making a game such as Gravity Force, where there's not a ton of stuff moving on the screen and you want it perfectly 50 FPS and perfect lowest possible input lag. So for shooters and stuff, it is a good idea. Especially if you're not running full frame rate. Well, if you're not running full frame rate, you can't raise the raster, so you'll need a buffer. So you'll then have half the frame rate plus the input lag of the buffering. Not using buffers is the most responsive update method for the screen. Use it if you can. The buffer pointers are correct, but I'm not really sure why. Let's check if the scroller at least updates 50 FPS here. does. And here's our buffer swaps. We got rid of the trail after the cloud. And the speed is half because we are double buffering the coordinates. So you could see it as two sets of coordinates, each updating 1 pixel every other frame, and that's why the cloud is slower now. It still doesn't quite explain why. It seems to stagger. Let's check that again and see if it's just WinUAE that doesn't vertical sync. It shouldn't. It should record at 50 FPS. Be close enough. And then we have this delay even though so we can safely do this to make sure it wraps sooner, just to test it. So what I'm looking to do is getting rid of the part where it starts showing on the left side again and showing incorrectly. It goes completely off screen and then immediately appears on the side, which is not what we want. And we can't subtract more than that. How is this? How is this not working? No, this is a monolithic operation. It works on the same coordinate. There's no buffer swaps in between loading and storing here. And as soon as it hits 320 plus 112, that is the total width. So let's see now. On coordinate 0, the cloud is outside the left border of the screen. We would like to move it the width of the screen plus 112 pixels to make it go completely off screen first. But for some reason, it wraps too late. Starting coordinate is 0. Can remove this now, by the way. So the wrap coordinate in X is correct. Is the subtraction value correct? Well, it must be, because otherwise it will instantly appear onto the screen in the left part of the screen. Leave that for now and have a think about these separately updated coordinate lists. Might not be a good idea. Might be better to copy. As I said, you can use a history buffer. And I think that is what I'm going to do. I'm going to make a simple list of coordinates. It can be in the same format. And the only difference is we don't double buffer it, because if we do, it will update one buffered coordinate list first, draw that, move to the other coordinate list, update that the next frame and show that, but it won't get to the first one until 2 frames later, and that's why it's slow. So what we do instead is replace this pointer. We no longer swap this pointer. We use the first list as the current list, which means that we will have to split the clearing and the drawing of the bobs into two loops later on, because when we clear it, we need to load list 2, which is the history buffer, which is where we're going to copy the coordinates into after. So this now needs to be split into clear clouds and plot clouds. There's no other way. In my present state of mind, I should add. No, it's not 1 a.m. right now. It is just after 10 p.m. So that's the history buffer, and this is fine. Now this is a crucial piece of code that needs to be moved. This needs to be copied verbatim, everything except, and we'll add widths and heights into the list as well. But for now, this should work for the only cloud that we have in the demo at this point. So now we have them separated, and this should no longer act on the history buffer, right? It should act on the current buffer, active buffer. We can move it after. And these can later be made into two loops, a clear loop and a plot loop. Now to update the structures. See if we have them here. This can go. We can say that this is the active buffer. And this is the history buffer. And we no longer swap these. So now it's faster. We're getting more exciting phenomena on the screen. And still a bugged entrance on the left side. This is what you get for being rusty. I suppose. We can examine the lists and compare them. And the reason why we get the bug is because list number 2 is not updated, which I simply forgot to add the part that copies the active buffer into the history buffer. And that's what's going to take place now. This is hopelessly overkill for this demo, but it's a good demonstration, I suppose. We can now do this. And this. And just do a plain copy. That's the size of the list in bytes. And we're using words, so we can't really. Do we want to add width and height? It's still going to be an odd number of words. So let's do that and subtract 1 for the counter. And simply copy. Copy the words. Let's double check this. Copies from A0 to A1. Seems to have the correct number of words. So that is now fixed. And now we have a single list of coordinates continually updated across 2 buffers. And we save away with this copy loop, we save away the old values, the old x values for the clouds, the old coordinates of the clouds, so that we may clear them correctly. And we still have the trail. It is fascinating sometimes. I'm not happy with the cloud shaking like that. Seems to me it shakes more than the scroller. So this might also be up to. We can still examine the lists. The lists consisting of 1 set of coordinates, which is equal, which is why the plot bug is there. So the timing of this copy is wrong. It should be, the old value should be copied before the cloud is moved. We still have the trail, we still have the shaky cloud, and we still haven't fixed the wrap issue. It is fascinating sometimes. I'll have a look around and be right back. Alright, we are back, and I was right the first time. And I was also right in saying that you can do it with the history buffer as well. But if you have 2 buffers, it has to be a history buffer of 2 steps back. So the previous history buffer has the previous position, and the one before it has the position of 2 buffers ago, 2 screen buffers ago. So back we go to swapping these to follow the buffers. This is no longer active and history. This is now 2 buffered coordinate lists belonging to uh, the to each screen buffer. And we have this to swap. We did remove the swap. We'll have to check again how to deal with this. Now we have separated it into clear and plot already. We do not swap this anymore. We don't need to copy this into a history buffer anymore. We have to think about when to move them. When we clear the cloud, we should read the accurate coordinate buffer and read the old value. This means the one we draw into. This is no longer correct. So this was the frame we drew into 2 frames ago. Now we look to erase those clouds and move them and draw them into the same buffer again. This means that these are the old values. This is still correct. We then need to move the clouds because we cleared the old and we plot the new. That was the big conceptual mistake I made. And we can now do this, say move clouds. Now these coordinates should still go in the same buffer. I need to move them separately, I believe. We should not swap buffers in between. This belongs in the loop, of course. Because the order in which we read from the pointer A3 is critical. And we move them before plotting. We no longer need this. This is now coherent for the first buffer. Currently we're just using the single buffer with this name. We'll need to make this a move again to read buffered. Let's move it. So it's the same draw buffer, but we're using the old positions here for all the bobs. And we move them before we plot them. And then we have to think of when to swap buffer anywhere before or after this should be fine. It doesn't necessarily have to map a certain list to a certain buffer. That is to say, screen buffer 2 doesn't have to map to coordinate list 2. And we can also correct some other bugs that we have right now. Let's see where we are here. I have a feeling that the reason the cloud is staggering is because this is in the wrong place. It should be in the right place, because what we're doing is we are setting the show buffer, poking that into the copper that is definitely showing this vertical blank. And in order to not make it stagger like that, we swap the buffer before we draw the clouds here. Because we read the first word here when we draw. So don't ask me why this doesn't work, but let's put back the coordinate list buffering again. And I do have a quick command for grabbing the word you're standing on, but I keep forgetting. I think it's Control G. Can check it. Yeah, it is. Okay. And this part doesn't care about what A1 is pointing to, because because it's pointing into the copper before here. Now, if this is incorrect, it's incorrect. And then we had a conceptual mistake in that we hard-coded, sort of. Let's see where we read the bitplane pointers from. Weird. Where were we? Cop sky bitplane pointers. No, that's not the one. That's the one. It's our buffer list for the screen. There we go. And that's initialized in the init. And the wrong thing we did was we should have left this offset. This offset is just for the pointers in the copper list. And that's why the discrepancy. So it's offset twice over to the right when we plot. The screen buffers are still the screen buffers, and only the bitplane pointers displayed by the copper should be offset. So this should be without this. We could have kept our loop. So sky buffer list, but that's fine as is. And now we have correct base pointers for the memory allocated for the screen buffers that we draw into. And now we have to put the offset back into the copper list. Check for any more stray plus 14. That initialization is still correct. That's fine. For now, because it's cleared. This should now give us a correctly wrapping staggered cloud with a plotted trail behind it. with a possible plot trail behind it. So you can see that the cloud now appears. So that, okay, no plot trail. That means that our buffering of the coordinate lists is working. Now we check the wrap. And that seems okay. So, riddle me this. Why do I have to move this? So now I'm feared I should move both because they belong together. And it doesn't really matter which list is which. And you're telling me that I should move it to before poking the pointers. And then everything will work. Which doesn't make sense to me at all. I swap the buffers first and then poke the same pointer into the copper list as I'm drawing into. Does not make a single iota of sense, but there we go. It's perfect. So this shows some of the head scratching you have to do with double buffering and screen offsets. And now we should add some more clouds, don't you think? Because we haven't used much of the raster time. So all this is an exercise just in order to add something more on the screen to use up the raster time. Could have made these playfields faster, for example, by splitting the back playfield into sections and have every cloud that shouldn't overlap another could be a separate scrolling field and take half a scan line of raster time to execute. But instead we're making a mini game. We can pretend that these clouds are, game objects and they're flying around and having fun. Now we need to make the width and height dynamic because I am about to include the two other sizes of clouds. And we'll make a few. We add these at the end because we don't want to disturb the structure in the list. We'll type comments after this, what the numbers mean. And because we're not copying anymore and using a history buffer that's at least 2 frames back to cope with double buffering, it doesn't matter that we're duplicating data. It's going to be very few bytes. And in fact, we'll just copy paste all the information from here. I'm tempted to take this in baby steps. Let's include the binaries first. don't remember. I've strategically made the widths match 16 pixel boundaries just to save on the, and then we'll see if the shift works out if I did that correctly. Otherwise I'll have to do it over. I can actually check that from the sizes. We need to make these the same as these, or I'll have to go into the IFF converter again and do it correctly. 1596, you say. No, they're exactly right. So we are done here. Those are the clouds we're using. And I can now change the list to match. Get a different cloud out. Oh, I need to. Almost made a boo-boo. So this should be a plain copy of this data. So that it clears the same amount as it plots. We need to change the pointer to it. And these might also come from this buffered list. This means that you can have animated objects if you so desire. Now the wrap coordinate can still be the same. It's a matter of choice. You can put 320 into an available register and add the width to it and have it wrap sooner if you wish. That would be neater. That would be neater actually. Let's do that. That's the width. We're gonna get to it. And then do this. It is recommended to only make one change at a time, but I think I can manage. And now we need to remove these. And after we've added that, we can shift this down by 4, divide by 16. Fortunately, we can't change the order of these. We'll have to match the list, remember? We have the width. They seem to be coming in the correct order. However, these need to be moved after this, which is I'd like to have them like that. I'll have to reorder the coordinate list. I could move this shift operation into the bob plot because I'm saving that register away anyway. Let's do that, nice and clean. And that's not entirely correct. We need to do this. Round up, right? So let's see, if the width is 1, that becomes 16, that becomes 1 word. If it's 0, it becomes 15, becomes 0 words. If it's 17, it becomes 32 and becomes 2 words, which is correct. A little bit more code per bob, but we're not too many instructions. So we only changed the draw bob, I think. We need to go back here now and have a look at things. You can replace this with the actual we need to remove this, and this will alert us to any stray occurrences that need to be fixed. Let's see if we have it here. No, not really. So that is fine. And now we need to do for the clear what we did for the plot. And we need to reorder these so that the speed comes last. And we need to adjust this offset to match. Do we also want a pointer in there? I guess we do. So reasonably, the list should consist of the coordinates and a pointer to a structure that represents a bob. And that structure has a pointer to a bob and its width and height, and maybe its speed. That would be a way to do it if you were making it a game. Right now it's too much work to create an individual structure per cloud, I feel. So we'll have the pointer at the start of the list there. So this will be removed, replaced with reading from the list. We almost supplied the wrong mask for it. And we can now move this, whoopsie daisy, move this down with the other stuff. And that seems to be the draw part of things in order. So you must make sure that these match up exactly. And now we have the offset for the update of the moved coordinate. So we need to add 4 to that because we added width and height in between, which is fine. Could replace this with a move M. Just watch out for, well, we don't have to watch out for anything. For now it's good though. I can do that later. So you could do a move m.word a3 plus comma d0 through d3 to load those forwards, and it would be a few cycles quicker. You could do the same for this operation. Don't have it in my head if it breaks even or is faster or slower. Now let's make the structure match that. Now this is going to point perhaps into a different section because the bobs are in the chip section and this is in the fastmem section. We'll see if we have to move it. A few bytes in the chip mem won't hurt, won't be the end of times. And I just realized we need to load the masks as well. Let's double check where we read the speed value. In which order we read it. X, Y, width, height, speed. Right, that's how it's gotta be. I think it comes after. Let's verify that. Not you. You. Yeah, it comes at the very end after height. So that should be correct. And then we go back 2, 4, 6, 8, 10 because of the plus from the add. You could also move A3 to a different address register and just move it back into that address register, then it would not be dependent on the size of the structure. So are we done here? We are not reading the speed here. It doesn't hurt us now, but it will hurt us when we make this a loop. So we just included the bobs. Now we need to include the masks. I knew that. All seems hunky-dory. Let's see if we get a smaller cloud on the screen. It's not quite working. And I think that is because we need to make this bigger. So the 48 doesn't include the extra 16 pixels of margin. Apart from that, it seems to be working fine. So let me quickly go back in IFF converter and cut those out. Be right back. All right, let's update these. They are supposed to be one word wider now. And we'll also have to adjust the width and height in coordinates. Making sure that these match up as always. ZI is the zap include memory. Now I renamed them, obviously, since the dimensions changed. I renamed them. But if you update a file externally, you may need to zap include mem. Under some circumstances. And there's our smaller cloud now. We can see if it wraps in decent time, because that's a part of the code that we changed, and it does not. So the 112 has more to do with how much extra space we have outside the left margin than the width of the bob. We could change it back, or we could calculate exactly how much we want to subtract. It's too much work right now. Poor old photon. It was still a decent thing to move the height, the width into the bob routine, though. That's fine. Let's verify that the wrap works as it should. We might subtract less to make it appear quicker, and keep the constant number. It's a bit of a pause there. Let's do that then. Let's put the code back. This is the dynamic subtraction value. As soon as it's outside the screen, we need to subtract the width of the screen plus the width of the bob to make it go back in on the left side and appear quicker. And then we use the fixed one. To have a correct wrap value. It's a small change, it should work perfectly. So just because I started this cloud now on x coordinate 0, it takes a long time for it to come in on the screen. But we'll have some different speeds, and we'll have random x coordinates. And that seemed to work fine. So it's time to make this a loop and have a playfield of bobs. I was hoping to do this in the previous episode, but it was long enough as it was. Coding in general takes longer than you think. So now we have one correct bob. Now we need to make this a loop. We need to first provide some coordinates in different sizes. This is getting fun now. Let's prepare the list of bobs. Let's double check, actually, that the double buffering is working perfectly. Let's stick this at the very top of the screen. Make sure that it doesn't flicker from racing the beam. Now the flicker you see is the background color change that we are using to determine how much raster time we have left in the frame, not from the buffer swapping. all seems well. So let's get going. I think I want only one or two of the biggest clouds that will because that will fit more bobs on the screen and will in general look better. And this is the slowest speed I want. I'll use speed 1, 2, and 3. How about that? So let's get to work. Boom. Let's make 10. Most of them being cloud 3, which is the smallest cloud. And I wouldn't mind having this at the top. Would make sense with that. You could also sort them vertically so that the smaller clouds are at the horizon. That's actually a good idea. Let's make this a medium cloud. At the top, followed by a big cloud. Let's have some random coordinate. Let's make it. I'm gonna go crazy if I correct the comment columns all the time. I'm gonna accept uneven tab columns for now. Well, I can probably correct them and type double zeros or something. Let's have that 7. 007. And the width and height is correct for cloud 2. And the speed is medium. Then we want a big cloud. And we can overlap here. Now, after we're done, we're going to have to sort them in reverse Z order, because I don't want to write a sort routine and move these around in memory and stuff. You can also do it by reading the list and ticking off the clouds that you have drawn, but for now I'll make sort of a Shadow of the Beast-esque fanning out of the clouds in my mind's eye. And that was 112 by 48. Let's fix that. We'll have that quite a fair bit down, right? We'd like it to overlap, so let's put it on 7 plus 20 in Y vertically. We can have this at 0, that's fine. Width and height is correct, pointers are correct, speed is incorrect. I'd like this to be the fastest cloud. As an exercise, you can do these as sub-pixel precision objects. You can do all kinds of things where you, well, if this wasn't on a single playfield, you could make it so that you had sub-pixel, very slow clouds moving and being redrawn only when they move. You can still do that here in the screen buffer if they do not overlap, but I like to sort of demonstrate that they do overlap. So I'll do clumps of 2s and 3s that partially overlap. So are we now? We are a little bit down on the screen now. I'd like a gap here. So 27, 48, let's make that 30, 78, 85. This is the top most pixel line of the clouds that we're specifying with Y. And I'd like a small one and then a medium one overlapping. So let's move it down a little bit more. 200, 2000 is excessive. It would be fixed immediately after moving it, but the first plot would be incorrect. It would possibly be, it would be in the screen buffer. It wouldn't go out and trash memory, but it might end up in the wrong bit plane because the buffer is interleaved. And I like a small cloud. The width was 4815 and the speed is correct. And I want a big cloud again, so how about copying this? Don't want them, the big clouds, to match up. In X. If I can help it, they won't. Okay, so that's okay now. I wouldn't mind having this 240. I'll adjust them after. I want this to overlap now, so no higher, no lower down than 110. 105. Width and height and speed is correct. And that is probably the last big cloud then. And I'd like a small cloud here next, which also partially overlaps the big cloud. Might look bad. I'll move them inside the big cloud or whatever. Hundred and 153 is the bottom. Fine, let's have it. Let's have it at the bottom. So 150. And I'll build this list now. You get the idea. I'll build this list up now and come back to you when it's done. And I'm back. So after lots of editing and finally sorting them by speed, because speed is the z coordinate. The slowest moving clouds should be in the back. And with a total of 11 clouds, 3 big ones, 3 big whoppers, we can now check how much raster time we are left with. I've changed the background color change for checking the raster time left to red. We'll see if we can make it. So this is cycle exact with slow memory, which is the same speed as chip memory, just for compatibility with an A500 OCS 1 megabyte platform. So that's what the cloudy sky now looks like. You can tweak this further. You can see some unintended side effects, such as the raster bar appearing in front of the logo, well, behind the logo, but in front of the clouds. So that will have to be tweaked, and we'll have to write a scroll text. Might adjust some colors. But we are definitely getting closer, so I'll show you the changes I made to make it read more than one cloud from this list. First of all, it would be a good change to put a copy loop in the init to copy these coordinates to somewhere in the init here. I also made a fixed counter for the clouds. You can calculate that from the size of the structure divided, well, the total size of the list divided by the size of the structure, and make it dynamic. Or you could make it a variable for that matter. And then all I did to this single cloud plot and clear was to make put these two lines before it. I initialize the screen pointer at the start of the list, initialize the counter, set the label, and after it's cleared with this clear value, I repeat for that many times, and the same thing down here. So we have a clear loop and a draw loop. And because of the order in which the clouds are in the list, it draws the slow-moving clouds first, rendering them at the back, and the quick clouds, which are also bigger, at the front. And that results in this big playfield full of 3-bit plain bobs. So we are not clearing that playfield because it would take longer than clearing the individual bobs. But depending on the bob size and the bob count, an entire clear of the 3-bit planes might be quicker. So now we can enjoy the end of this Odyssey. It was longer than I anticipated, but it was good to show some of the bugs that can appear when you add double buffering after the fact, or to just part of a demo or part of a scene like we did now. And you can get a head scratcher even though the code itself is fairly basic. Not a whole lot of lines were added to the source, but it's about where you place them and how you build the structures to make the buffering happen. You can also observe now that we have one thing left to fix, and that is to mirror the clouds in the bottom reflective plane. Thanks for watching. We can enjoy this for a few seconds. Catch you in the next one.